Yeah, good morning. I, Dr. Devesh Bandel, Associate Professor, Suresh Gyan Vihar University, accredited by NEC A grade. Today, I will discuss about pseudocode and implementation of your selection sort. You know, when you want to write the pseudocode and implementation of your selection sort, so before write the pseudocode and implementation, you should know about what is selection sort, what is the algorithm of your selection sort, and major important thing is that student should know about how selection sort will work. Means example of your selection sort. Okay, your selection sort is the part of your data structure and algorithm. Selection sort is one of the sorting algorithm of your sorting topic. You know, if we will talk about the sorting where you will arrange the your item in your sorted fashion. Suppose like you are having a unsorted array and you want to sort this particular array, so you will apply the so many techniques of your sorting, like your selection sort, merge sort, quick sort, like your radix sort and insertion sort. The selection sort is the one of the most important technique of your sorting, and today I will discuss about the implementation and the pseudo code of your sorting algorithm, that is your selection sort. In this lecture, I will take the example of your selection sort, and also I will write the algorithm of your selection sort, because if your example and your algorithm of selection sort is clear, then you can write the implementation and your pseudo code of your selection sort in your easy way. In this lecture, I will cover so many topics of your selection sort, means implementation of your selection sort. First of all, I will discuss about the object and outcome of your selection sort. After that, I will discuss about the selection sort and so many topics. I hope you can see my screen, and today's my topic is that pseudo code and implementation of your selection sort. In this lecture, I will cover so many topics of your selection sort, like your object and outcome, overview of your selection sort, what is the selection sort in your data structure, example of your selection sort, implementation of your selection sort, and advantage and disadvantage of your selection sort. You know, the main objective of your selection sort for understand the concept of your selection sort, where you can apply the selection sort when you want to apply the when you want to apply the selection sort, so you will take which type of array for selection sort. Like you will take the limited size of array, or you will take the large size of array, because so many algorithms of your selection sort are working on a limited size of your array, and many working of sorting algorithms will work on your large size of your array. Okay, so object of your this lecture is that to understand the concept of your selection sort, and if we will talk about the outcome of your selection sort, so after studying this lecture, student will able to concept of your selection sort. For the selection sort, which type of array is required, like either limited size of array is required, and either large size of array is required. And also student will able to how to write the pseudo code of your selection sort, and also student will able to how to implement the selection sort. If we will talk about the overview of your selection sort, you know, as per I had told, selection sort is the one of the most sorting algorithm of your sorting. And the selection sort an array by repeatedly finding the minimum element, and considering the ascending order from unsorted part and putting it at the beginning. As per I had told, in your selection sort, you will repeatedly find the minimum element from your array. Like suppose you are having an array, and in your arrays there are so many elements are existing. So when you will apply the selection sort on this particular array, you will repeatedly find the minimum element of this array. Okay, and after find the minimum element, just you will put at the beginning of your array. And now, what is selection sort? You know, selection sort is your simple algorithm of your sorting algorithms. The main focus is that this algorithm is based on your comparison based algorithm. Means in this algorithm, you will apply the concept of your comparison based. Comparison based means in this algorithm, you will compare the two element. When you will compare the two element, obviously your one element will greater than from the adjacent element, and maybe your one element will less than from your adjacent element. The main key point of this algorithm is your comparison based algorithm. Your selection sort is based on your comparison based algorithm, and which is divided in two parts: the sorted part at the left hand, and the unsorted part at the right hand. Initially, the your sorted path will empty, and your unsorted part is the entire list. This will happen at your initial position, means when you will start. Okay, so in this selection sort algorithm, you know, as per I had told, this algorithm is based on your comparison based algorithm. And in this algorithm, you will repeatedly find the minimum element. Okay. And because this algorithm is your comparison based, so your minimum element will compare to the other elements of your array. If your element is greater than from your adjacent element, that time your swapping is required. And if your element is less than from your adjacent element, that time your swapping is no required. Okay. And as per I had told, your list is divided into two parts, in your sublist, in your left hand side list, and your right hand side sublist. As per I had told, your list is divided in two lists in two subarray. In your first subarray is your left hand side of list, and your second subarray is your right hand side from the list. And I had also told the smallest element is selected from the unsorted array. Means you will select the smallest element from the given array. Okay. And swapped with the leftmost element, and that element become a part of the sorted array. Okay. And this process continue moving unsorted array boundary by one element to the right. This is the technique of your selection sort algorithm. Means when you will apply the selection sort in your particular array, so you will follow this technique. Means in this technique you will find the minimum element from the unsorted array, and your minimum element will compare from the other elements. And if your leftmost element is greater than from your adjacent element, that time your swapping is required. Okay. And now I am taking the example of your selection sort. In this example, I have taken a unsorted array, and your unsorted array is that 14, 33, 27, 10, 35, 19, 42, and 44. Total 8 elements I have taken in your particular array. And for the first position in the sorted list, the whole list is scanned sequentially. And the first position, you can see in this given slide, your 14 is placed on your first position. Okay, is sorted presently. We search the whole list and find that 10 is the lowest value. Means when you will find the lowest element in your particular array, so you have to find that 10 is the lowest element in this particular array. And you can see the lowest element I had marked in your red color. So now your array is that 14, 33, 27, 10, 35, 19, 42, and your 44. And 10 is the lowest element in this particular array. And I had marked in your red color. And you know, 14 is your first element of your array, and 10 is the lowest element of the array. And as per I had told, as per the technique of your selection sort, you will find the lowest element, and the lowest element will compare from the first element of your array. And you know, your first element of the array is your 14, that is placed in your first position of your array, and 10 is the lowest element. So 10 will compare from the 14, because I had already said that this algorithm is based on your comparison based algorithm. As per I had told, this algorithm is based on your comparison based algorithm. So when you will compare the 10 from your 14, that time you know 10 is the less than from your 14. So as per the sorting, your 10 will come first and 14 will come after the 10. But when you will compare the 10 from 14, 10 is the minimum element from your 14. 10 is the minimum compared than your 14. So that time your swapping is required. You know, swapping means if you are taking the two variable, so your first variable will take the value of your second variable, and your second variable will take the value of your first variable. That is your swapping. For example, suppose I am having the two variable like your P and Q, and in your P and Q, the value of your P is 10 and the value of Q is your 20. So after swapping, your P variable will take the value of your Q and your Q variable will take the value of your P. And for the swapping, you can apply the two technique. First technique is that you will you can take the third variable, and without third variable you can swap. If I am taking the third variable, suppose that is your temp, in your first statement for the swapping you will write your temp assignment operator P. And when this first statement of your swapping will execute, the value of P, that is your 10, will assign into your temporary variable, that is your temp. And in your second statement, when you will write P assignment operator Q, P assignment operator Q means your the value of key will assign into your P. You know, the value of Q is your 20, so your 20 will assign into your P. So that time your temp variable will have the value is 10 and the P variable will have the value is 20. And in your third statement, you will write the Q equal to temp, sorry, Q assignment operator temp. And when your third statement will execute, your temp value will assign into your Q, that is your 10. Okay. So after execution of your all steps, all three steps, your value had to be swapped, and that time your variable P will take the value of Q, that is your 20, and your Q will take the value of your P, that is your 10. So this is the concept of your swapping. Okay. So your I had told your swapping is required when your first element is greater than from the adjacent element. That time your swapping is required. In this given slide, I have replaced 14 bit 10 after one iteration 10, which happened to be the minimum value in the list, appears in the first position of the sorted list. Now your new array will be 10, 33, 27, 14, 35, 19, 42, and 44. You can see in this given slide, I had marked the 10 value in your green color, means that is your sorted. And in your starting, I had already told your list is divided in two parts, in your left array and your right array. In your left array, you will insert those items who are already sorted, and in your right array you will insert the all items which, sorry, those are not sorted. Okay, so as per I had told, your list is divided at this time in two parts, in your left part which contain the 10, and in your right part which contain the 33, 27, 14, 35, 19, 42, and your 44. And for the second position, where 33 is residing, we start the scanning the rest of the list in your linear manner. So you can see when you have to start it, when you have to start it, you have to find your 14. 14 is the minimum value from the unsorted array which contain the item 33, 27, 14, 35, 19, 42, and 44. And 14 is the minimum value. Okay. And after two iteration, the list value are positioned at the beginning in your sorted manner. So your 14 will compare from your 33. Okay. When your 14 will compare from the 33, your 14 is less than from your 33, and your 33 greater than from your 14. So after swapping, your 14 will take the place of your 33 element, and your 33 will take the place of your 14 element, as per you can see in this given slide. And after that, your two element I had marked in your green color, which are 10 and 40, and your rest elements of your unsorted array, which are 27, 33, 35, 19, 42, and your 44. And the same process is applied to the rest of the items in your array. You know, I had told in your right hand side summary, you will insert only those items which are not in your sorting fashion, like your 27, 33, 35, 19, 42, and 44. And now you can see your 19 is the lowest value from these right hand side unsorted array, and your 19 will compare from your 27. When your 19 will compare from your 27, that time your swapping is required. So you know your after swapping, your 19 will take the place of your 27, and your 27 will take the place of your 90, the 19 element. Okay. And you can see in this given slide, 19 I had marked in your red color, and your 19 will swap from your 27, and your 27 will swap from your 90. After swapping, I had told 19 will take the place of your 27 value, and 27 will take the place of your 19 value. And that time, your new array will look like 10, 14, 19, which are sorted. And I had already inserted in your leftmost subarray, because I had told your all sorted items will be inserted in your leftmost array, and in your right part array you will insert the only those items which are not in your sorting fashion. And now again you will repeat from your unsorted array, means you will find the minimum element, that is your 27, and your 27 will compare from your 33. You know your 27 is less than from your 33, so that time your swapping is required. And after swapping, your 27 will take the place of your 33 value, and your 33 will take the place of your 27, the location, 27 value location. Okay. And after that, your new array will look like 10, 14, 19, 27, 35, 33, 42, and 44. You know, 35, 33, 42, and 44 is your right side array. And because these elements are not sorted in sorting fashion, again you will apply, again you will find the lowest value from the unsorted array, that is your 33. And again your 33 will compare from your 35. You know your 33 is less than from your 35, that time your swapping is required. And 33 will take the place of your 35, and 35 will take the place of your 33 element. And after swapping, you can see your new array look 10, 14, 19, 27, and your 33, 35, 42, and your 44. Okay, here you can see your entire array is divided into your two parts, as per I had told in your at your beginning. In your left hand side array, your all sorted elements, and in your right hand side array, your all sorted element 35, 42, and 44. Means now your array has to be sorted, and your new array like 10, 14, 19, 27, 33, 35, 42, and your 44. So this is your array in your sorting fashion, because in this list your each element is less than from your adjacent element. 10 is less than from your 14, 14 is less than from your 19, 19 is less than from your 27, 27 less than from your 33, 33 less than from your 35, 35 less than from 42, and your 42 less than from your 44. I hope all are understood about the example of your selection sort. After example of your selection sort, I am discussing about the algorithm of your selection sort. You know, I had told, and all students are known about the algorithm. Algorithm is your step-by-step instructions. Means if we will talk about this particular algorithm, that is your sorting algorithm. In your sorting algorithm, which steps you have to follow for solve this problem? Only you will write these steps only in your sequentially fashion, in your orderly. That is your algorithm. because there is no any foundation ki you will write the algorithm. First of all, you will write this statement. After that, you will write this step. After that, you will write this step. There is no any foundation. Okay. So only algorithm is that only step by step instructions as per you have done in your example of your selection sort. Okay. In your step of your algorithms are, first of all, you will set min is your variable to location 0, and step 2 you will search the minimum element in your list as per you have I have done in your example. And in your third step, swap the value at the location. And in your fourth step, increment mean to point the next element. And in your step 5, and your you will repeat until your list is sorted. That is the algorithm of your sorted. You know, I had wrote this algorithm as per I told the all steps of your example of selection sort algorithm. And now, if we will talk about the implementation of your selection sort and pseudocode of your selection sort algorithm, first of all, you will make a function of your selection sort. Okay, you will make a procedure of your selection sort, right? In your selection sort procedure, first of all, you will take the list, you will take the array, because if you are not having the array, means you are not having the items, so you can't apply the any sorting algorithm because you are not having any items. That's why you will take the array of your size. So first of all, you will take the array, and you will also take the list of your size, because I had told many some algorithms are applied in only limited size of your array, and your some algorithms was apply in your large size of your array. In your implementation, you will take the your array, you will take the items in your array, you will take the elements in your array, and also you will take the size of your list. Okay. And when you will implement this algorithm, so first of all you will take the array, and in your array you will insert the items. Okay. And also you will take the size of your array, and you will apply a loop from I to n minus 1. I to n minus 1, because suppose you are having an array and your array size is your 10. Okay. So your loop will start from your 1 to 9. Means your first iteration is the first iteration is required, second iteration is required, third iteration is required, fourth iteration is required, fifth iteration is required, till to nine iteration is required, because you are having the only 10 elements. Your array size is your 10 elements. Okay. And after that, you will set current as a minimum, and you have to define the minimum assignment operator. Your I means the value of I will assign into your minimum. And And after that, you will apply a loop which start from your I plus 1 to n. And in this loop, as per I had told, if your first item of your array is less than of your least element of your array, so that time your the value of your j will assign into your min. And if your least element in this above example I have taken, your 10 is the least element of your array and 14 is the first element of your array. So if your least element, if your minimum element is less than from your first element of your array, so that time your swapping is required. And you will follow the all steps of your swapping. Means your 10, that is your minimum value of your array, will take the place of your 14 value, and your 14 will take the place of your 10 value. Okay. And I have also written a comment: swap the minimum element with the current element. Okay. And as per example I have also mentioned. And when your procedure will start, obviously your procedure should be finished. And after that, if we will talk about the advantage of your selection sort, advantage of your selection sort, there are so many advantage of your selection sort. A main advantage is your this algorithm is that it perform well on a small list. I had told some algorithm, some sorting technique are applied only in your small size of your array. Means your some sorting techniques are suitable for your small size of your array, and your some sorting technique are suitable for your large size of your array. The selection sort, main advantage of the selection sort is that it perform well on a small list. Means if you will take the small list, if you will take the small size or size of your array, your selection sort, and you want to apply the selection sort, so your selection sort will give the best performance. Okay. Because it is in place of your sorting algorithm, no additional temporary storage is required. And your second advantage is that additional temporary storage is not required. Okay. If your additional temporary storage is not required, so obviously your memory will consume in your less amount. As per I had told, no additional temporary storage required beyond what is needed to hold the original list. And next advantage is that its performance is easily influenced by the initial ordering of the items before the sorting process. Okay. And after that, disadvantage of your selection sort algorithm. As per I had told, your selection sort algorithm is applied only on a small size of your array. If you are taking the large size of your array and you are applying the selection sort, so your selection sort algorithm is very poor for the large size of your array. Means this algorithm will give the performance is very poor. And if you will take the small size of your array, your this algorithm will give the best performance. and the succession sort required n square number of steps for sorting L elements, and the another technique of your selection sort, like that is your quick sort. Quick sort is much more efficient than the selection sort. Okay, so these are the advantage of your selection sort. Here I am here. I had mentioned the some questions which are based on your selection sort, like your in following scenario, when will you use the selection sort? So the selection sort is based on your key. Hence, a file with large value and a small key can be efficiently sorted with the selection sort. And your options are, means when will you use selection sort? The input is already sorted. A large file has to be sorted. Large value need to be sorted with a small key, and the small value need to be sorted with the large key. Obviously, your answer will be C. And another question: what is an place of your sorting algorithm? So auxiliary memory is required for the sorting the data temporary, and in these questions your options are, it needs one and log n memory to create auxiliary location, and the input is already sorted in place, and it required the additional storage, it required the additional space. So the selection sort not required the additional space in your memory. And auxiliary memory is required for storing the data temporarily. So it needs the one and log n memory to create the auxiliary locations. And advantage of your section sort over other sorting technique, so it required no additional storage space. It is scalable. It work best for input which are already sorted. It is faster than the other sorting algorithm. So I had already told it required the no additional storage space. And next question is that what is the average case complexity of your selection sort? N log n, log n, and your n square. I had told in this algorithm, n square steps is required. That's why your answer is that average case complexity of your selection sort is your n square, because in the average case, even if the input is partially sorted, section sort behave as the if the entire array is not sorted, the selection sort is a incentive to input. So your answer will be D, that is your n square. And what is the advantage of your selection sort? The main disadvantage of your selection sort, it is not scalable. As the input size increase, the performance of selection sort will be decreased. Means if your element will increase in your array, so obviously the performance of your selection sort will decrease. And the given array, suppose your given array is your 3 4 5 2 1, means the given array size is your 5. The number of iteration in the section sort are required. So obviously your 4 iteration are required. Because the input array is not sorted, and the selection sort will take the n minus 1 iterations. N minus 1 iterations means n is your array size, n is your list size. Okay, if n is your list size, in this question If you are taking the array size is your 5, so or your only 4 iteration are required. It means you will apply the rule is your n minus 1, and where n is n equal to 5, so 5 minus 1 means your 4 iteration is required. And what is the best complexity of your selection sort? N log n, n and n square. The best average and worst case complexity of your selection sort, as per I had told, n square, n minus 1 plus n minus 2 plus n minus 3 dot 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 equal to n minus 1 upon 2 equal to n square. So after studying this lecture, student will able to where your selection sort will apply. For the selection sort input, limited size of array is best, or large size of array is best. Also student will able to how to write the implementation of your selection sort, how to write the algorithm of your selection sort. Okay.